Hello everyone! In this track, we will talk about a machine learning project where Unicred made the journey since the extraction from the data until gets insights from that data using machine learning in AWS. I am Amanda Quinto and I am working with public sector in Brazil, helping customers to drive their solutions using AWS. Thanks for watching this session. I am really flattered to be part of reInvent this year. So let's get started. Here is the schedule of what we will discuss today. We will start the conversation talking about the challenge that we will face, and then go to the technical part, talking about the architecture design and best practices that we use in this project. And then we will have a brief of the customer and finish with the results achieved with the project. But first, let's meet Unicred. With more than 30 years on the Brazilian credit union market, Unicred was founded to manage the resources of the Unimed system, which is the national confederation of medical cooperatives in Brazil. And the founders believe that a credit union is the more democratic way of splitting profits between the members. Actually, Unicred has more than 2,020 active members and around 208 business units. And the Unicred system is present in more than 60% of the Brazilian states. And the main services offered by Unicred are personal insurances, are personal credits and insurances. We should keep that in mind because we will revisit that information later. The percentage of customers that stop using a company's products or services during a particular period is called customer churn. And that has become a significant problem, is one of the prime challenges that many companies are having to face. And is increasing considerably over time in the financial sector, being driven by the rise of digital banks, with the growing trend of the competition in the sector. According to McKinsey, between 2013 and 2018, churn rates grew 13 points around the world in the financial sector. Unicred is not away from that problem and start thinking that maybe uses data could help them to better understand the profile of the member who is likely to stop using the company services. So let's figure out how Unicred uses AWS services to develop a project to help to solve that challenge. But first, let's understand what is AWS well architected and how that framework was used to drive the decisions during the project. AWS well architected helps cloud architects to build secure, high-performing, resilient, and efficient infrastructure for their applications and workloads in AWS. It's based on five pillars: operational excellence, security, reliability, performance efficiency, and cost optimization. The AWS architects provide a consistent approach for customers and partners to evaluate their architectures and implement designs that can scale over time. And around May 2020, AWS launched the well-architected framework Analytics Links, which follows the same five pillars, but for analytics projects. In this project, the pillar of focus was performance efficiency, using serverless always that was possible, in the most part of the architecture actually, because using this kind of services, like AWS Lambda, AWS DynamoDB, we don't need to worry about high availability or scalability, for example, because those services solve that question natively. Using multiple workflows on AWS step functions to guarantee that any flow was independent, and, for example, to start training without having to deploy all the infrastructure over and over again. The choice made about AWS Glue makes it easier to create jobs to specifically solve ETL problems without having to carry about provision any virtual machine or thinking about the idleness of the environment. Security is priority for AWS, and for that, in this use case, in each layer, security was considered. The communication between the services is all private, and we are using internal load balancer when it's possible. We use EIM roles and policies in each service too. So, for example, for AWS Lambdas communicate with Amazon S3, we use the idea of least privilege in the policies in the EIM role. I know that you are probably never heard about any of these services and is curious about what the Unicred developed. So let's see the architecture here. I know that seems a lot of things, but we will go through all services here and understand why and how they are interconnected that way. So, first of all, let's talk about data sources. All the data that is used to train the models, is stored in PostgreSQL. That Postgres is inside the Unicred data center. This data is something like the customer's age, the marital status, the products that the customer already is using from Unicred, and a few other pieces of information. To extract that data and make the ingestion into S3, that will become a data lake really soon, Unicred uses Pentaho. That makes Pentaho make the aggregations and then upload that data into S3 using S3 API for that process, and then put this data inside a raw folder. After that, the process and the analysis of that data gets started. But before we continue with that process, we need to understand what is AWS S3 and why is this service so important for our architecture. So AWS S3 is the Amazon Simple Storage Service, which is an object storage that increases both horizontally both for performance and storage according to the customer's needs. So, for example, in this case, Unicred is only use a few gigas of data into S3, but they can scale and increase this data to terabytes or even petabytes without need to provision any capabilities first, any capabilities of storage or even of computational. And this service is serverless, so you don't need to provision any virtual machine to use AWS S3, and is fully managed by AWS. Now that you know what is AWS S3, let's keep going with the architecture. Here in the process, we use AWS step functions to do the orchestration of each step. AWS step functions is a serverless function orchestrator that makes it easy to sequence AWS Lambdas and multiple other AWS services for business critical applications. So you can use AWS step functions to put together a lot of different AWS functions, for example, and orchestrate this kind of service. You can also use AWS step functions to trigger other workflows inside the step functions. We use that approach here with 3 different workflows. So let's move on to understand these other workflows. And first, if you are not aware, AWS Lambda is a fully managed serverless where you just care about your code and let AWS deal with the infrastructure. So the first workflow is named ETL. We are using AWS Lambda to get a few informations on the data to create the rest of the stack. So, for example, Glue jobs and SageMaker jobs are all created based with the information that we get from the data. Whenever a new process starts, with new data being sent to AWS S3, the process of creating the stack is done from scratch. So it's based on the data that is found in S3. The first Lambda here gets that information, then start a series of validations in that data for then start the process. And you are probably ask yourself, what is AWS Glue? AWS Glue is a fully managed extract, transform, and load, so ETL service that makes it easy to prepare and load your data for analytics. We will use AWS Glue in two steps here in the architecture. First, in the ETL workflow. So after creating all jobs and all stuff using AWS Lambda, the AWS Glue get that data into the raw folder on S3 and starts some standardizing and cleaning of this data. And then it starts the other workflow here, that is the train models workflow. But to understand how this workflow to train models works, we need to start to understand what is Amazon SageMaker. So Amazon SageMaker is a fully managed service that provides the ability to build, train, and deploy machine learning models quickly. SageMaker removes the heavy lift from each step of the machine learning process to make it easy to develop high-quality models. SageMaker here trained 3 different models with 3 different algorithms. So we are using the algorithms LGBM, XGBoost, and CatBoost. Those 3 different models, and is going to be more than 5 really soon, are trained and compared using MLflow. One thing that is important here, these 3 different trainings are done in parallel, using SageMaker API through step functions. This brought a performance gain. Remember that we talk about the performance efficiency pillar. Because as they are trained in parallel, it's possible to retrain or compare the results at the end of the training, without having to wait to train each model in the same infrastructure, something that could take hours in the data center. So imagine that you have to train first the LGBM algorithm with the data, and then wait for the end of this training, for then start the other training with XGBoost, for example. That took some time and is not really performance approach. So here we are training these 3 different models in parallel. But let's understand what is MLflow here. So this is the architecture of MLflow. MLflow is an open source platform to manage the machine learning lifecycle, including experimentation, reproducibility, deployment, and a central model registry. In this scenario, Unicred uses MLflow inside a container running into ECS. So before the migration, before starting this project in AWS, the Unicred was using MLflow in a single container running in a virtual machine in the data center. So for example, if this container falls, something happened with this container, the data scientist loses all the information there. He needs to start these containers manually, so wasn't a really resilient architecture. Here in AWS, we migrate this MLflow architecture using Elastic Container Services, the relational database services, and application load balancer. Remember that this application load balancer is intern for this architecture, right? In this way, the MLflow has become a resilient solution that scales according to the demand. And the services here are all managed by AWS. We also use 2 availability zones here to guarantee that each container of the MLflow is isolated between AZs. we also care about security. So the subnets are both private, and as I said, we are using an internal load balancer and a private RDS. Think about cost optimization, that is another pillar of our architected framework. We don't need much containers to run MLflow. We can work with only 2 containers, for example. So there is no need to provision EC2 only for a couple containers. So for that, we decided to use AWS ECS with Fargage, where Unicred is only paying for what are using without the waste of the operational capabilities. These solutions helps to compare the results of the models to check if they fit each other and there is no unconformity between the results. Here is a print screen that demonstrates one of the comparisons made by MLflow to help Unicred to always use the best model, the model that we had the better results and the fit that train in a better way, always tuning the hyperparameters, for example. But let's get started to our architecture here. A Lambda selects the best model and compares it with the current production model by searching through MLflow models repository. If it finds a new model, the workflow then redeploys a new version to SageMaker. Alright, in the final workflow here, named Generated Results, SageMaker Bets generated a model prediction and uploads the results in 3 different sources: AWS S3, DynamoDB, and PostgreSQL, inside a Unicred data center. The inference is not made in the real time, so the results are available in these 3 different sources and can be used whenever is needed. And just to keep the pattern, Amazon DynamoDB is a key value and document database that delivers a single-digit millisecond performance at any scale. It's also serverless, so you don't need to worry about provision a virtual machine and styling and configuring any database in the SEO or something like that. Now that we discuss the entire architecture here, we understand that how each company is connected with other component or resource in AWS. It's important to say that in the final part where the users consume the information, they are using a few APIs through Sensidia, and there are other users from the BI team consuming that information through Power BI that is connected to the PostgreSQL inside the Unicred data center. So, looking through this architecture, all the resources here are serverless. That removes the complexity of provision, management, and reduce costs because you only pay for what you are really using. As I said in the MLflow infrastructure slide, security is priority for AWS. So this S3 bucket is completely private, the data is anonymized, and the connections between the services fully made using EIM roles with restrictive policies. This architecture here using the step functions workflow can also work independently. So for example, to do some validations based on any MLflow recommendation, so change this parameter from the model, something like that, it's possible to start, for example, and use the workflow train models without had to trigger the other models. So you can start and stop the triggers between the workflows here. That brings some performance and also some possibilities that the data scientists can use to develop other models based on other algorithms, for example, and also train that in parallel in the workflow train models. So put other algorithms to train using the same data, because in the workflow train models we are using the SageMaker job, using the SageMaker API through step function. So it brings that possibilities too. So now, let's listen in the voice of the customer how AWS helps them to use their data to create business insights. So Rafael, please join us and tell how that project initiates and what was the challenges in your view.
Hello, my name is Rafael Silva, and I am the leader of the data science team at Unicred of Brazil. I'll tell you a little bit about our journey with machine learning using Amazon Web Services. So, a few years ago, we started thinking about how we could use machine learning approaches to understand our customers' behavior and how they use our products and services. With that, our goals were to predict which product or service we could recommend to each customer, which fit better at that moment in his life. And at the same time, we want to understand how much of our services our customers was using and how likely he would be to end his relationship with us. For this, we want to be one step ahead to reduce our churn rates. Based on that, we started very small, doing some experiments. And for that, we had some machines available in your data center. At that time, we had a few computational resources. And as this project became more relevant to our company, we needed to be more efficient. So, at that point, we talked to the Amazon Solutions team, and then we started a project design to see how we could bring our machine learning, experimental, and production environments to the cloud. It took some weeks and some meetings to understand and select the best tools to provide us a secure and scalable environment. In a few months, our data engineers, together with the Amazon Solutions team, built a cloud-based architecture using the Amazon services to achieve our goals in the best way and using the best practices. And now, we have a secure and resilient environment with a lot of computational resources that can scale up to our needs. Today, we're able to train multiple machine learning models in parallel and select which one might be the best fit for each experiment. And all this in just a few minutes. Now our data scientists no longer need to be concerned with the performance of our environment. They can focus entirely on how to improve our models so we can reach even better results. And the most importantly, we are bringing a great commercial value to our company. So, this is our journey so far, but I believe that we still improve this working model even more, always with the partnership of Amazon. Thanks for watching this. I hope you have a nice session. Bye.
Thanks for sharing, Rafael. And finally, let's figure out what Unicred has as an achievement of that project. So first, the prediction models creates lists of customers that could be a potential customer that will stop using the Unicred services. So then Unicred's account managers made a proactive job calling those customers and trying to understand why they seem dissatisfied and how Unicred could help them to use different products, or even with some offers, something like that. So with that, Unicred could retain these customers by 13% in the first month of that project. And also using the same architecture. Remember that in the beginning we discussed what products Unicred has. So using the same architecture, data, and workflows, Unicred could increase by 10% the sales revenue by predicting the right product for the right customer using machine learning in AWS. So that architecture that we have been discussing in the past minutes was used for two ideas in Unicred. So first of all, to reduce the churn, and second, to increase the sales in the company. So using data in AWS, a few services, and the idea of the well-architected to develop resilience and performance architecture brought some results in only a month of project in Unicred. Here, a few resources that you can use to keep developing projects well architected in AWS. So, a few links that you can use to develop your projects in AWS. Thanks for sharing this session. I am Amanda Quinto, and this is my contact. So, if you have any questions, please let me know.